Okay, let's say you are driving your car. Here's a car. I have a little picture here. You start out at time 0. You haven't gone any distance. So in a Cartesian plot here where the x-axis is time, the y-axis is miles, you haven't gone any distance yet. But now you start to drive and you slowly speed up. Then you get on the highway and you move at a constant speed. Then you get off the highway and you slow down. You're in the neighborhood where you're going to go, maybe grandma's house, and you get to your destination after some period of time. Maybe this is 2 hours. I'll just put 2, since we know that time is in hours. So maybe this is 2, and you've gone 100 miles total. Well, what's your average speed that you traveled there? Well, the average speed, if you went 100 miles in 2 hours, your average speed is what? It's 100 over 2. I mean, that makes perfect sense. Equals 50. Your average speed was 50 miles per hour. Well, that makes perfectly good sense. Everybody kind of has a feel for that. Well, what we've done here is we've found, let's get rid of that and use a different color. What we've done is we've found, essentially, we connected these 2 points. We call this a secant line. Any line that connects 2 points on a curve is called a secant line. What we've done is we've connected these 2 points, and we went and we found the slope of this line, essentially, right? So m equals, what was it? It was 100 minus 0 over 2 minus 0. So this is like x2, y2, and this was x1, y1. So a general equation for that is, oops, not x is on the top. We always have rise over run, so the y's have to go on the top. So it's y2 minus y1 over x2 minus x1. Well, we call this, if the orange curve is a function, and of course it is a function, you can tell, you can do the vertical line test and it satisfies it. We call this the average rate of change. In particular, between the interval x equals 0 and x equals 2 for 2 hours. I've gone and filled in the curve a little more. Now, suppose we look at another point on this curve at the 3/4 hour mark. In 3/4 of an hour, we've traveled 25 miles. Well, we could do the same thing. We could find our average rate of change between these 2 points. And it's going to be a different slope. And based on how this looks on my plot, it better be a smaller number than 50. So let's check it out. So this was case A. So in case B, m equals, so y2 is 25 minus y1 is again 0 over x2 is 3/4 minus 0. So that's the same thing as 25 times 4 divided by 3 equals 100 over 3, which is what? 33 1/3. Multiply 33 1/3 by 3, you get 100. So 33 1/3. Wow, miles per hour is our average rate of change between these 2 points. And we could do that between any 2 points. We could actually select this point and this point here if we wanted to do that. And I'll leave that up to you to look at other average rates of change between the other points, any points on this plot. But what's interesting is if we juxtapose that with what we would call the instantaneous rate of change, which is not a secant line, does not connect 2 points on the curve. The instantaneous rate of change, that's going to be confusing. Let's get rid of this secant here. Okay, this green line is a tangent line. It's just 1 point. It's a tangent line at 1 point. This represents the instantaneous. Rate of change. And how does that relate to our automobile? Well, the average rate of change is like our average. It's what you're going to get if you're using your trip tracker in your car. The calculator will calculate that, your average mileage, your average rate of change. But the instantaneous rate of change is any given instant. You look down at your speedometer and you see what your current speed is. That's what an instantaneous rate of change is. And that's how it relates to an average rate of change. If you ever hear these two ideas discussed at the same time, you'll know what the difference is between them. Well, if we have a function, one way we can look at this is if I choose some x value, this is going to produce some y value like we were saying. And if I choose an x value over here, again, this will produce some y2 value, this x2 value here. And we did say that our slope was y2 minus y1 over x2 minus x1 if we are doing average rate of change between those 2 points. I guess I didn't really say we were, but yeah, that's what we're going to do. Average rate of change between these 2 points here. So I'm drawing a secant line. Let's make it something other than green. Turn it into a blue line. So our average rate of change here is going to be that relationship. Well, we can think of it this way. We know that y2 really is just f of x2, and y1 is f of y1. So I can kind of rethink this and say that this is f of x2 minus f of x1 over x2 minus x1. So in this way, we can do this average rate of change. We can find average rate of change of functions without graphing them. Say we have 2x squared plus 3x minus 8. And we want to find the average rate of change. Now we have to have an interval. Let's say x equals 0 to x equals 1. Make it something that we can quickly do easily. Well, what I want to do then is I got to figure out my point pairs. I got to figure out 2 points. And I only have the x values here, so I need the y values. So that means I'll have to find f of. So let's look at it this way. If we have the x value in our point, we need our y value. So if we have 0 as one of our x values, our y value is f of 0 equals 2 times 0 plus 3 times 0 minus 8 equals minus 8. So that's the point pair 0, minus 8. So that's like a point, and, well, it is a point, not just like one. And then we have f of 1 equals 2 times 1 squared plus 3 times 1 minus 8. So that looks like 2 plus 3 is 5, minus 8 is minus 3. 2 plus 3 is 5, minus 8 is minus 3. So this is the point pair 1 minus 3. So now we can do our slope, or average rate of change, between these 2 points in this function is going to be f of 1 minus, let's go f of 1, let's go the bigger value here, minus 0, 2 over the x values of 1 minus 0. So this f of 1 so this is really 0, f of 0. So f of 1 is down here, which was minus 3, and f of 0 is up here, which is minus 8, minus 3 minus a minus 8, divided by 1 minus 0. So this turns out to be minus 3 plus 8, which is 5, over 1 equals 5. So the average rate of change between these 2 points is 5. So here's what a plot of this looks like. I put it in math way and plotted it. Here we're looking at, this is the y-axis, this is the x-axis. So I'm interested in the interval 0 to 1. So, as we said, when x is 0, y is minus 8. When x is 1, y is minus 3. And what I did was I drew a secant line then between these two, essentially. Took the slope of it. That's real close to the instantaneous rate of change. You can see that the slope is real close to the actual curve. And that slope is positive 5, as we found. Makes sense. It's a positive slope. Looks like 5. We could do a quick rise over run and figure that out on this plot.